Okay, today we are going to talk about estimation. Estimation uh, is based on distributions. And so what is the purpose of estimation? And I'm going to just pull up a short file. I'm not going to look at the entire file. You can read that file and then understand what estimation is about. But I will explain it first. So I'll share a file. And I'm going to post this file for your benefit and for the benefit of class. So here we're talking about confidence interval estimation. Okay. After I explain it, I'm then going to pull up the PowerPoint slide that goes through estimation, and then we're going to do some examples to illustrate what estimation is about. And then you can ask questions. Now, in applied statistics, we do what is called a sampling. And we use that sampling to do estimation. So what is the objective of estimation? What is the objective of confidence interval estimation? I'm going to post this file for the benefit of everybody, those who are here today and those who are not. We use sampling to find information about a population, okay? Because it is not usually possible or necessary to inspect an entire population, and for the following reasons, okay? Now, sometimes to contact the whole population would often be very time-consuming. What's the population? Let us think about what we call population, okay? Think about all the students who are registered at Medgar Evers College. That's a population. Now think about all the students that attended school on a particular day. That's also a population because you're talking about everybody. Okay? Now, suppose you wanted to find out what is the average travel time of students that came to school today. Two things could happen. One, you will not be able to know everybody that came to school today unless you stand at some gate and identify everybody that walked in. That will be time consuming, that will be unnecessarily expensive. And so what you do then is you can walk into a classroom or you can stand at some point and you take, say, a sample of 20 students or 30 students or 40 students and ask, how long did it take you to travel to school today? And they tell you 10 minutes, 25 minutes, 50 minutes, 90 minutes, 40 minutes. You are taking a sample and you are going to use information from that sample to make a judgment about the population, which is to say you would take a sample of 30 students, you could go and walk into a classroom of 30 students and ask everybody there how long it took them to get to school today. What could cause you to do that? We just want to know typically how long does it take a student to get to school? Or it could be on a snowy day, and those who braved the snow to come to school, you say, how long did it take you? Because you want to estimate how long it takes a student to get to school on a snowy day. Okay? All right. So The problem there is what? What is the problem? The problem is you don't know the true average time it takes a student to come to school today. And so you want to get information from a sample in order to make a judgment about the population, about everybody. Think about a restaurant owner. Now, numerous people come to the restaurant on a particular day or even over a period of time. And so you want to find out what is the average expenditure of a customer that comes into the restaurant. What is the average amount that they spend on food? Well, you will not be able to know the exact population of everybody that ever comes to that restaurant, maybe over 6 months, maybe over 3 months, maybe over 9 months. And so you can get the receipts over a period of, say, 3 months and say, during this 3-month period, maybe during the Easter period, or maybe during the spring season, and you take a sample of 60 receipts or 80 receipts, a random sample, and then look at the amount that each customer, each of the 60, 80, 90, or 100 customers spent. That will give you an average of the amount that customers spend. But it does not have to be a true average. In fact, it cannot be a true average because you don't know what potential number of customers over other years during that season spent. And so you use information from the sample to make a judgment about the population. And so the judgment we're trying to make here is, what is the average amount that customers spend? What is the average age of the customers that come to this restaurant? What is the average income of the kinds of customers that come to this restaurant? So that is our problem. We don't know what the true average is. We do not know what the true average is. But we want to use information from a sample to make a judgment about a true average. And so we do an estimate, what we call a confidence interval estimate. The average customer that comes to this restaurant spends between amount A and amount B, spends between $40 or between $12 and $18. You estimate that and say you have a 90% confidence or 99% confidence that this is what the average customer spends. So how do we go about that confidence interval estimation? We begin with what we call a point estimate. That is to say, you take 80 customers, you take 60 customers, whatever the sample size, you ask yourself, you take receipts and look at each receipt and see how much was spent. And so you now calculate the average expenditure of customers based on those receipts. That gives you what you call your point estimate. And then using that point estimate, you now calculate a lower value and an upper value and say, with 95% confidence, with 98% confidence, the average customer spends between so amount like $9 and so amount, say, like $12. And so the question then is, how do we go about that? Okay. For example, a sample of 100 recent accounting graduates reveals a mean starting salary of $30,000. That is your point estimate. Okay, you take a sample of 100 accounting graduates, ask about their salaries, and you get an average about 30,000. That's a point estimate, and it's called a sample mean. Okay, it's called a sample mean. And then you use that to estimate what is the true average. The true average is not the 30,000. That's a point estimate. You want to estimate a range of values. So you select what you call a level of confidence, say 95%. It could be 99%. And so how do you estimate? How do you estimate?
That equation that's there, is that the equation that we're going to be using to do the estimation?
Yes. And I'm going to illustrate you how the estimation is done. Okay. I'm going to pull up an example. I'm going to stop share this, and I'm going to pull up an example. Right? And we are going to use the normal distribution, the standard normal distribution with the Z to illustrate how we go about doing the estimation. Okay. So I'm going to do an example, and again, go through this PowerPoint slide. After I go through the PowerPoint slide, you will be able to, this is what we did last week, okay? Confidence intervals. So what is the problem here? We're going to go through it again. We have a subject, customers, students, the salary of teachers, the salary of accounting graduates, their income, okay? We know there are 1 million of them, but we cannot go to every single one of 1 million of the graduates to find out what salary they made. If we can get that information, then we have what we call the true population mean. So we do not know the true population mean. Our objective is to use information from the sample, that is the point estimate, and we'll call it sample mean, X bar, to estimate the true mu, the true population average. So we take a sample of size n, sample size 80, 60, 70, 40, 30, okay? If the sample size is more than 30, we'll call it a large sample. So today we're going to begin with how to estimate with a large sample. We will still learn how to estimate with a small sample. So let's begin with the large sample. Calculate the sample mean, and then we'll calculate the sample standard deviation. We select a confidence interval, okay? For example, 95% or 97% or 98%. Now, once we select the confidence interval of, say, 95%, then we select a Z value. Based on our reading, what we did last week on normal distribution, what is the Z value for a 95% confidence interval? Okay. Now, the specific interval that we use is based on our choice. If you select 95%, you're simply saying that you have a 95% confidence. That's a 5% chance you could be wrong. Okay. If we select a 99% confidence interval, then we're saying we're 99% confident. It means there's a 1% chance you could be wrong. All right. Here's an example. A survey of 58 private colleges provided a summary statistics where X bar, the sample mean, is 180.975. Okay? And a sample standard deviation of 143.042. Let us calculate a 99% confidence interval for the mean endowment. So the amount you are seeing here is in millions, okay? It's in millions. So calculate a 99% confidence interval for the mean endowment of all the private colleges in the United States, assuming a normal distribution for the endowments. Okay? Now, in the US, there is more than 58 private colleges. So 58 is just a sample. Okay? If we were able to collect data on all of them, then we will be able to calculate the true average, but we can't. We do not have data on all the colleges. So we make do with information from the sample. Okay, so we calculate the sample mean, and it gave us 180.95. We calculate the sample standard deviation, it gave us 143.02, and the sample size n is 58. So we select a confidence level. It could be 97%, it could be 98, it could be 99. And so we choose a z value. Okay? So this is the confidence interval estimation. Okay? This 1 minus alpha, so it's 95% confidence interval. So there's an alpha percent you could be wrong. Okay? Which is the alpha is your margin of error. So if you do 95% confidence interval, then that means there's a 5% margin of error. Let me see, before we get back here, we select the z value. Okay, 95%. Okay, now you realize that in this normal distribution, are you seeing my cursor?
Yes, I see it.
Okay, you can see that half of the distribution is 50% and half of the distribution on that side is 50%. So if you're going to do a 95% confidence interval, that means that 95 over 2, which is 47.5, is going to be on one side, and the other 47.5 is going to be on the other side. If you divide 95 by 2, you're going to get 0.475. Am I correct?
Yeah, that is correct.
Okay. So you come in here, you see 0.475, where my cursor is.
Yeah, I see it.
Is it? Good. So the corresponding z value is 1.9, and you go to the right, and under that you get 0.06, so it's 1.96. That is the corresponding z value you are going to use.
I'm
You get that
following.
point?
Yeah.
Okay. Okay, suppose it was a 97% confidence. If you divide 97 by 2, you are going to get what? 0.4785. Am I correct? No. 97 over 2 is 0.48, okay? So your confidence interval, your z, your corresponding z value will be what?
For 97, it'll be 0.4756.
It will be 48.5. If you divide 97 by 2, it will be 0.485.
Oh, I see, I see. But
Okay.
okay, so hold on. Just now on the last example, I know that the 0.4750 is half.
Okay.
Um, but then when you said the at the end, you said that it was 0.47.5. Then you was like you said it was 96. So what is that? So we have the 1.5
No, 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 no. Okay, so I guess
and the point 0.6 is
now when you take a 95% confidence,
uh-huh.
divide 95 by 2, what do you get? Use your
Okay.
calculator.
Okay. Hold on. You said 95 by 2. It's 47.5, which is the
Very
same.
good. 0.475, right?
Mm-hmm.
Okay, this is 0.475. Are you seeing my cursor?
Yes.
Okay, the corresponding z-value goes from 1.9 and you go over here to 0.06.
0.06.
So your corresponding z-value will be 1.96. It is 1.96 you're going to use to do the calculation. And I'm going to go back to the formula. You can see where we plug it into the calculation.
Okay.
And I said that the next question we ask, suppose we chose a 97% confidence.
Mm-hmm.
Divide 97% by 2. What do you get?
48.5.
Very good. So you see 48.5.
Uh-huh.
Good. The corresponding z-value will be 2.1 down to here, which will be 2.17. You see
Mm-hmm.
that?
Mm-hmm.
Okay. So you write that 2.17 down, or you write 1.96 down, whatever confidence level you choose, you divide it by 2 and look for it in this table,
Mm-hmm.
and then write down that z-value.
Okay.
Okay. So let's go back now to our calculation. Okay. All right. So this is the calculation. So for a 95% confidence interval, you will say that C is equal to your sample mean X bar minus 1.96 times the standard deviation over the square root of n. And so your mean value, your true mean, will be between the left-hand calculation and the right-hand calculation, where the right-hand calculation is X bar plus 1.96 times the standard deviation over the square root of n. So let's use that to solve our example. All right. The 97% confidence interval for the endowment will then be X bar minus 2.17 times sigma over root n, which is the left-hand result, and the mean will be between the left-hand result and the right-hand result. Okay? All right. And so, remember the standard deviation was 143.042. Am I correct?
Yes, that's correct.
Okay. All right. So our confidence interval will then be 180, which is the sample mean, minus 2.17 times 143 over the square root of 58, which is 2.17 times 18.782. And the right-hand result will be 180 plus 2.17 times 18.782. 18.782 is the result of 143.042 divided by the square root of 58. Is that clear to you?
I'm trying to follow.
Okay. Take the square root of 58 and divide it into 143.042 and see what you get. Take the square root of 58.
Okay, hold on. The square root of 58. I can't help you. Sorry, Professor.
Fine.
You said I'm dividing it by 143.0.
So divide it into it. That means take 143.042 and divide it by the square root of 58. What do you
Okay.
get?
1.43. 143. I got, hold on, 18.78. It's like a long number. I just rounded it.
But how did you get 18.78? Because the square root of 58
Is 7.6158.
okay.
I guess we could say it's 7.62. And then divide.
So you take 143 and divide it by 7.62.
Mm-hmm.
What do you get?
18.7.
Good. Multiply, it cannot be that.
You said it can't be that?
No.
Do it again.
143 divided by
143.
square root of 58. Okay, you get, you are correct. You are correct. You are absolutely correct. Yeah, you get 18.782.
Mm-hmm.
Okay, fine. You are absolutely correct. Then multiply it by 2.17.
Multiply the 18 by 2.17.
You multiply that 18.782 by 2.17, your Z value.
2.17 is 40.7.
Very good. So that means that the true mean, the true average endowment is between 180 minus 40.757 and 180 plus 40.757. That is what the true average endowment is. Okay? So we get 140.217 between 140.217 and 221.73. We do not know the true average endowment, but with 97% confidence, which means we could be 3%, there's a 3% chance we could be wrong, but with 97% confidence, we can state that it lies between 140.2 and 221.7. See what the confidence interval means?
Yeah, no, I see it now.
You see it? Okay. So that is the subject of today's lecture. And so you can take that, okay? You can take that, and if you want to do a 99% confidence, if you want to be 99% confident, you do another estimation. And I have some examples that you calculate from a software, okay? Okay, so I've provided some examples, and you can use that example to solve a lot of other problems. So do you have any questions?
No, I'm gonna work through the examples.
Okay. And there's the file that I brought up, the Word file, that will give you a full lecture. You can use that. You can use these PowerPoint slides, and that will also give you a full lecture. And we have some examples there, and you can use that to solve any problem of this kind. You get it?
Yep, I got you.
All right, then. Thank you very much for coming. If you have no other questions.
No problem, no problem. Thanks,
Uh,
Professor.
all right, have a nice evening.
You too.